Welcome to a presentation of the Vishay NTCLE350 series of thermistors, the peak-insulated leaded components with an extended temperature range up to 185 degrees C. The NTCLE350 components withstand very high temperatures and harsh atmospheres, thanks to special epoxy used to insulate the thermosensitive bead and its good adhesion on the peak-insulated lead wire. The special nickel-iron alloy used for the conducting wires has a very low thermal conductivity, which prevents heat flowing away from the measured hotspot. There is nearly no gradient along the wire, and this ensures an ultimate measurement of the real effective temperature. Tolerance is plus or minus 1% at 25 degrees C and ensures a measurement accuracy of plus or minus 0.2 degrees C at ambient temperatures. The electrical R25 range and the tolerances on the curve variations provide an accuracy of plus or minus 2 degrees C at 185 degrees C. The NTCLE350 can be used in any automotive applications. It can be used in thermal engines as well as electric and hybrid vehicles for functions like ECT, engine cooling temperature, TMAP, manifold air pressure and temperature, OTS, oil temperature sensors, and EGR, exhaust gas recirculation, to name but a few. The NTCLE350 can also be used in HVAC applications. The NTCLE350 can be designed in very easily to a wide number of diverse applications. ACQ200 reliability test results are available from Vishay and show that this component is ideal for use in automotive applications. Resistance temperature curves and 3D models can be downloaded online, as well as a dynamic SPICE model where the temperature is driven by a virtual voltage. Integrating this model in any EDA software will enable engineers to complete their design more quickly and may also develop their intuition for the design. If you click on the Simulate button in the graph under the schematics, a short video will show you a simulation of a simple application involving the SPICE model of the NTCLE350. In this LT SPICE simulation, we generate a voltage output, Vout, for an op-amp, which amplifies a Wheatstone bridge based on an extended temperature range NTCLE350 thermistor. The simulation sweeps the temperature up to 190 degrees C and is performed as a Monte Carlo analysis. All passive elements are scattered within their tolerance. Within a few seconds, 710 simulations are completed. We then obtain the voltage signal needed to input to an analog to digital converter, ADC, in order to control the temperature in our application. We end this presentation with a snippet of comparative benchmarking for the NTCLE350. Here, we compare competitors' extended temperature thermistors. Without going into the fine details, we can see that Vishay has the highest number of green checked boxes. Only one of the competitors had a capability to offer ACQ200 products. But even here, the Vishay NTCLE350 outperformed this competitor in our testing. The major advantage was in the area of robustness and mechanical integrity after testing. Clicking on the Show button will provide the illustration of our results after we immersed both samples in salt water. After thermocycling and immersion in the salt water while under voltage, some of the competitor parts showed significant traces of wire corrosion through the coating and under the ceramic. At the termination, the wire could partly dissolve by electrolysis, while the Vishay parts showed no degradation after the same test. In conclusion, the NTCLE350 provides the ideal design component for harsh and high temperature applications, and especially for automotive designs.